So I want to show you guys a couple examples of trig equations that use tangent. So from Friday we went over how to get the graph, and I may use the graph. We'll see if we need it as we go on through these problems. So to start this one, again, we want to isolate the trig function. So I want to isolate tan x. So I'm going to add 1 to both sides. So I'm going to have tan x is equal to -1. From here, take the inverse of both sides. Okay, so I'd have x is equal to inverse tangent of -1. So if you remember from Friday, the trick for tangent using our hand is it's the number of fingers below, or the square root of the number of fingers below, divided by the number of fingers above, or the square root above. So if we think about how can we get a division that equals 1, well, that's got to be the same finger above and below. So if I pull in my 45-degree finger, I get 2 fingers below over 2 fingers above. They're both square roots, but that doesn't matter. A number divided by itself is 1. So I know that my reference is 45. Now, I don't want to write x is equal to 45 because x isn't 45. 45, the ratio is 1. This is -1. So what does the 45 play into? Well, that's your reference angle. Okay? So if I were to look at the coordinate plane, and remember all students take calculus, all right? Tangent is negative, second quadrant, fourth quadrant. So my reference is 45 degrees in those two quadrants. So my answer is going to be, well, this is 45 degrees less than 180. So that is 135. And this is 45 degrees less than 360. So 360 minus 45 is 315. And there are my solutions for that equation. All right, moving on. Next one. We have 9 times tan x is equal to 3 times square root 3. So again, divide by 9 to start. So I get tan x is equal to 3 square root 3 over 9. Which that reduces. 3/9 is 1/3, so I get tan x is square root 3 over 3. All right. So now I take the inverse of both sides. Okay, again, you don't have to write the inverse on the outside of those two like I did here. Okay, it's assumed that that's what you're doing when you read this from step to step, so this is fine. All right, now square root 3 is over 3 is a little bit tricky, because if you think, okay, on my fingers, this is the square root of fingers below. Well, I gotta fold in this one to get 3 below, but now there's not 3 above. So what's going on there? You have to realize that this has been rationalized. So the square root 3 over 3, if we unrationalize it, is equivalent to 1 over square root 3. And that allows us to use our hand. Okay, that allows us to say, okay, I need 1 below and 3 above. Well, that's this finger here. That's your 30-degree finger. So that means x is equal to 30 degrees. And also, so that's your first quadrant angle. Where else is tangent positive? Well, tangent's also positive in the third quadrant. So this angle is 30 degrees. Okay? So that angle is 180 plus 30. So that's 210 degrees. Now, we have two equations that are slightly different because the directions say solve each equation for theta between negative pi and pi. So if we get angles that are past pi, we need to write them as negative angles. That's what that's telling us. Okay, so remember, when you're moving around the coordinate plane, to get negative angles, you have to move this way. Okay, so we're gonna come across this, and I wanna show you how to figure this. So let's start with the first one. We have 14/3 is equal to 5 minus 1/3 tan theta. So I'm gonna start by subtracting 5. All right, so I got to start off by doing some fractions. So I have 14/3. I would do this off to the side again, but I just don't want to go off frame. So I'd have 14/3 minus 5. Well, I needed as a denominator 3, so that's 15/3. So that's going to be negative 1/3. So I'm going to have negative 1/3 is equal to negative 1/3 times tangent theta. All right, so now I need to get rid of that multiplication by 1/3. So I'm going to multiply by negative 3. All right, so I'm multiplying both sides by negative 3. These cancel out to make 1, so on the right-hand side, I'm just left with tangent theta. On this side, negative 3 times negative 1/3 is just positive 1. Okay, taking the inverse of both sides, I have theta is equal to the inverse tangent of 1. All right, well, we did that earlier. Okay, well, we did negative 1, but same idea. The reference angle is going to be 45, so that's good. So we're in radians, so pi over 4 is one angle. Now, the other angle is going to be the third quadrant angle that has a reference of pi over 4. However, we can't go past 180. We need theta to be less than 180, but greater than negative theta. So we need to write this angle as a negative angle going this way. Well, if we're going this way, okay, we're just shy of negative pi. So what would that be? Well, this angle going this way would be negative pi plus pi over 4, which is negative 3 pi over 4. So there's our solutions. All right, and that satisfies this criteria. Now on the assignment, I didn't have you do this weird interval. I only did this because your IB book has it this way, so I want you to at least be exposed to it. But I think if you're familiar with what I did with from 0 to 360, you can do all this stuff. Just takes a little bit of thinking. So I deleted the original problem 4 that was over here because it was the same answer and I wanted to go with something different. So let's look at this one. We have 1 minus 1/2 tan theta is equal to 1. Subtract 1 from both sides, you have negative 1/2. Tan theta is equal to 0. Multiply both sides by negative 2. You'd still get 0 there. So now the inverse tangent of 0. All right, now you can do this on your hand, okay? And you would get, in order to get 0, we need 0 fingers below, and it doesn't matter how many are above, because 0 divided by anything is 0. So the finger would be your 0 degree finger or your 0 radian finger, okay? It's in this interval, so theta is going to equal 0. Now, if you remember the graph for tangent, okay, there's the graph of tangent. So the inverse tangent of 0 says, what's the x value that corresponds to a y value of 0? So this is 0. This is pi over 2. This is pi. Okay, now, are we within this interval? We're no longer in this interval because it's strictly less than pi. Well, what other angle is going to have that same placement? Negative pi is. If we were to draw this side, okay, if you were to continue this, that'd be negative pi over 2. Here would be negative pi. All right, so between here and here, the solutions are here at negative pi, also at 0. But here, since it's less than, you can kind of treat this as we're only looking at the part of the graph. Stops there. Okay, it starts there, it stops there. So those are our solutions, 0 and negative pi. All right, hope this video helps. Let me know if you have any questions. Talk to you later.